Now we get to have some fun with the DHCP server itself. In fact, let me minimize this and bring open that DHCP console where you can see that I've actually gone ahead and created a little DHCP zone here, or DHCP scope, that corresponds with 192.168.0.30 through 0.50. So essentially just a series of 20 addresses here as a sample address pool that we can use for determining what should happen when the machine is healthy versus when it isn't healthy. One of the first things we need to do for this scope is actually enable network access protection on the scope itself. So we'll use the default network access protection profile for enabling this scope. Once we've done that, then we need here within the scope, and specifically the scope options, to go through changing the characteristics of that DHCP address that will be delivered to the client based on whether or not it passes or fails its health check. Now normally, well, back in the old versions, if you right-clicked here and chose to configure the options, here under Advanced is where you could set some of those options that would make the difference between whether or not the machine was healthy or not. But those have actually been moved, and they've been relocated over here into what are called DHCP policies. We need here to create a healthy policy and really an unhealthy policy. And we're not going to do any craziness here with moving computers onto different networks. Because this is DHCP, let's instead make things very simple on ourselves and give an unhealthy client a different DNS suffix. So our traditional suffix here is company.pri. But again, just for the purposes of explaining this, let's create an unhealthy.company.pri as the DNS suffix should that machine fail that health check. Let's start first by creating the policy that defines what characteristics those clients get when they're healthy. So this is the healthy policy here. For this healthy policy, we then need to configure a condition that would occur when, in our case, the user class is not equal to the default network access protection class. So when that client is unhealthy, it will get added into that NAP class. We are now creating the policy for what happens when it's not part of that unhealthy class. I'll choose OK here and choose Next. And then for the healthy clients, let's put them in 192.168.0.30 through 192.168.0.39. So the first 9 addresses there in that zone or that scope. I'll choose Next also. And then here we need to identify just the other characteristics that are common to a DHCP scope, like the router, 192.168.0.1, like our DNS server as well, which can be 0.100 in this environment, 0.100. And here we'll also choose the DNS suffix as well, being company.pri. So I'll scroll down here, and right there, the DNS domain name being company.pri. Once we've done here, that completes the good policy that we need to set up here for our DHCP server. But we also then need to set the unhealthy policy as well. So here's our second policy, which is our unhealthy policy, which will essentially reverse or invert from the previous policy. So our user class now equals the network access protection class. And in doing so, let's go back now here and change which IP addresses the machine would get, 0.40 through 192.168.0.50 in our case. Choose Next again, and then set up all those original configurations as well. So here's our router, 192.168.0.1, as well as our DNS server, 0.100. And most importantly then, after I get this plugged in, is the DNS suffix, which will adjust to be unhealthy.company.pri. Now, the whole point here is that I'm attempting to set up just something so that you can visibly see the difference between what happens when a client is healthy or unhealthy. In a production world, we are actually trying to physically separate out and quarantine those clients into some other location. This is not really going to do you much good, but it gives you at least an initial feel for what NAP intends to accomplish. So here is our unhealthy.company.pri suffix here, which I'll choose Finish. And that now configures DHCP so that it will give out different characteristics in that address that it delivers to any requesting machine, depending on whether or not that machine passes its SHV.